welcome Orange, and he's travelled all the way from Taiwan. That's a hell of a long way. We're looking forward to hearing your presentation, Confusion Attacks, Exploiting Hidden Semantic Ambiguity in Apache HTTP Server. Welcome Orange.
Okay, hi. Okay, hi, I'm Orange, and it's my pleasure to become a speaker at Httpd. And the next session I'm going to talk about is the research and attack surface I discovered in Apache HTTP Server. First, I want to ask, is there anyone here who hasn't heard of Apache HTTP Server before? If so, please raise your hand. Well, almost all people have heard of that. I think I can skip the introduction. But let's still give you a quick overview. First, Apache is an open source project that's nearly 30 years old. So it might be older than some of you here. And because Apache has existed since the early days of the internet, it has accumulated a lot of technical depth. And Apache enabled CGI by default, which greatly increased its potential attack surface. And the last is that Apache is the only web server that can integrate it with PHP smoothly. Since Apache and PHP were born almost in the same year, in the early years, Apache was the only choice to use PHP. And PHP also made several customizations for Apache. So nowadays, there are a lot of ways to configure a PHP environment. For example, there are over 6 different modules just for the fast CGI protocol. And each module has different syntax. An interesting thing is that among those directives, some are not only looks very similar, but also have identical usage. So if a website admin did not understand the intention behind each directive, it's easy to make mistakes and create security issues. For example, when a website admin wants to set our PHP on his machine, he might come across 2 common directives, @handler and @type. And which one do you think is correct? Actually, both are correct. Both methods can properly get the PHP running. So does this mean both are good? Firstly, being correct does not mean being safe. And under certain conditions, @type has been proven to be vulnerable and allows the attackers to disclose the PHP source code remotely. And we will discuss the detail later. And the last thing I want to highlight is, from my year working in offensive security, I find that websites who use Apache web server tend to have messier environments. In practical, a lot of Apache servers are hosting a lot of third-party applications, such as the Tomcat or Nginx locally. They would love to use the rewrite rule to dispatch the request to the applications. And the file system on the server is also a mess, with a lot of strange files sitting on the web root. So today, our mission is to break this type of Apache HTTP server, identify such vulnerable servers, and learn how to break them all. Before we dive into our topic, let me introduce myself. Hi, I'm Orange, and currently I'm the principal security researcher at DevCore. I have spoken at several hacking conferences and got several honors, such as the Pounding Award and the Pound-to-Own Champion. So why do I focus on Apache? At the beginning of this year, I started to explore some high-impact open source projects. And while closely reviewing the Apache source, I smelled something bad in its coding style. First, Apache is comprised of over 100 of small modules. The source code includes 136 modules, and about half of them are either enabled by default or commonly used by website web server. And what's even more surprising is that these modules also share a very large structure while working together. This structure includes all the elements needed while handling a HTTP request. All modules rely on this big structure to synchronize, communicate, and even exchange data. A HTTP request will pass through several phases, and modules are like playing baseball, passing the structure from one to another. From the perspective of software engineering, this type of collaboration is not new. Each module simply focuses on its own task. And as long as everyone has done its work, the client can enjoy the service provided by the Apache HTTP Server. However, any module can update the structure at any time. So this approach might work well with a few modules. But when there are over 100 of the modules today, without any good standard or guidelines, can they still work together? So our research focuses on the relationship and the interactions between these modules. Each module might be implemented by different people and subjected to years of iterations and code refactors. Do the developers still know what they are doing? Even if they understand what they are doing, how about the implementation details in other modules? It's important that they have to work together. However, what if today a module accidentally modifies a field it considered unimportant, but is crucial to another module? It could affect the latter's decision. And also, if there is any misunderstanding on any field within this structure, it can also create security issues as well. So from this starting point, we create 3 different types of attacks. And because all of them are more or less related to the misuse of the structure, so we name this attack confusion attack. And following are the attacks we have so far: the file name confusion, document root confusion, and handler confusion. This is a completely new attack surface. The first person who delves into, of course, can find the most bugs easily. So this attack surface also made me the person who's currently holding the most vulnerabilities from Apache HTTP Server. And additionally, because these vulnerabilities are based on legacy architectural issues, Most of the patches are not backward compatible. So updating a patch to the latest version might back your configurations. So for many production servers, simply apply the update is not a good idea. So okay, let's go to our first attack. The first I would like to introduce the attack is called the Filename confusion. The attack happened when different modules handle the filename field using the different standards. Literally, the filename field should represent a file system path. But however, some modules treat it as a URL. So if inside a HTTP request, a module considers the field as a URL, but the others are not, the inconsistency between this module will create security issues. So which module consider the filename as a URL? The first is the rewrite rule. This module allowed the website admin to redirect the request to any file or URL. I believe this is by design for the user experience. However, this design also introduced certain issues. For example, even if the destination is a file system path, the rewrite module will treat all the results as a URL. For example, if a website admin sets the following rules to target the path right after the patent/user/ to open the corresponding profile. So when you access the /user/orange, the Apache will open and print out the file content of the /var/user/orange/profile.yaml. However, what if you add one more extra question mark today? The %3f is the URL encoded format for the question mark. So in the time of the name translation phase, the module will first process the rule to get the corresponding destination, just like this case. However, we said that the rewrite rule will treat, the rewrite module will treat all the destination as a URL. So to handle the URL, the module will split out the query string by the question mark. So here is a path truncation. And this is our first primitive. You can use a question mark to truncate the rest of the path. For example, here we use this truncation to access the file we can't reach originally. And for here, let's pause a little bit about how to export it. Also, this looks like a minor issue for now, but please remember it because we will use this behavior in our later attacks again and again. And let me introduce the next primitive, and so which module also consider the file name field as a URL. So does the proxy module. And at the first glance, it seems to make sense because the purpose of the proxy is to redirect the request to other URL. So when we consider this behavior on its own, it doesn't appear to be a problem. But however, if your web server relied on the file-based access control, it can be risky. For example, here is a common password-protected configuration using the files directive to prevent unauthorized users from accessing the admin.php. And this type of the authentication can be bypassed when the server is running under the PHP SPN. Imagine this scenario when today you are visiting this URL, the admin.php, %3f, and oo.php. In the time of the HTTP lifecycle, the authentication module will first compare your requested file name with the protected one. At this point, your file name is admin.php, :oo.php, which is totally different from admin.php. So Apache didn't think you need the authentication. However, to support various protocols like HTTP or FTP, the proxy module will rewrite the file name into this format. Use it as the file name and send it to the backend PHP service. Since the file name is in a URL format, the PHP also introduced some workarounds to adapt this behavior. So PHP will first normalize this unusual file name and split it by a (2) to get the original file name. So the original authentication required file can be bypassed with just a single (). Of course, it's not just admin.php. There are more risky configurations all over the world, such as the PHP info that is accessible locally, and adminer, which is blocked by default. All of these protections can be bypassed with just a single (). So this is our first attack, playing the inconsistency between the authentication module and the proxy module. The next attack we will introduce is the confusion based on the document root. First, this is a common configuration for the website admin will have to hide the file extension from the URL. So today, when you visit the URL http server /html/about, which file do you think Apache will actually open? Is it about.html under the root folder, or the file from the document root at /var/www/html? If you think it's the server will open the file under the root folder, please raise your hand. Okay, if you think the server will open the file under the document root, please raise your hand. Okay, the answer is it opened both. Magic, right? This is also what our second confusion is talking about. For any given rewrite rule, Apache always try to open both the path with and without document root. This allows us to access the files outside the web root, especially the root directory. So you might be wondering, hey, does this mean we can access the /etc/password? Yes, but not entirely. Technically, the server indeed accesses the password file. However, the built-in access control blocks our access. you can see the configuration denied all by default. But the interesting thing is that the built-in access control by default also allows the access to the folder /user/share. So thanks to this configuration, now we have a limited arbitrary file access on the Apache HTTP server. For example, we can access the documentation on the /user/share to learn how to use SSH. But however, there's a problem to access other files because we can only access the files with the extension .html. So you might wonder, can we access the file outside that? I'm not sure if you remember the primitive we have earlier. We can combine both attacks together using a question mark to truncate the extension part. So theoretically, as long as we can control the prefix of a rewrite rule, we can access the entire /user/share. This is a blast. Even the tutorial from the official Apache website has problematic examples. So, okay, now we understand the root cause, and what can we do? First, we can disclose server-side source code. Since Apache decides whether to execute a script or not based on the current virtual host, to access the full path through the virtual host who doesn't support PHP can easily expose its source code. And since we have broken the trust of the document root, the entire /user/share has now become our playground. So the next step is to find out what files we can leverage. Actually, there are lots of files we can exploit, such as the example tutorial, the test files, and even packages installed by the programming language. They can all become our gadgets. So the first gadget we are going to demonstrate is abusing the library office, which is installed by default on Ubuntu desktop. We can leverage the language switch feature in the help files to achieve accesses. Or we can disclose sensitive information. For example, if you install the WebSocket daemon, the service will, by default, include a PHP script called the .env.php. You can directly access this example file to leak sensitive information. And additionally, if the target installs the service like the Nginx or Jetty, the default web root is also on the /user/share. So you can download the web configuration, such as the web.xml, by a simple rewrite rule. Here we showed how to leak the sensitive information by accessing the set of files from the package devical. And more interesting is that even some PHP or front-end packages, their tutorial or debug console can be also leveraged as well. For example, here are some gadgets from the jQuery, Magpie, and the JPGraph. And we can, here we use the tutorial from the jQuery feed to read arbitrary file content. So for now, you can see this attack surface is huge. All the remaining is to find more powerful and universal gadgets. But this attack still seems a little bit not perfect. And you might be curious about, can we also jump out of the /user/share? And of course we can. That brings out to our third primitive, to jailbreak from the /user/share. That's because Apache, by default, follows the symbolic links. So we can leverage this feature to jump out of the /user/share. So any package that has a symbolic link can now become a stepping stone to access more gadgets for further exploitation. Here we list some useful gadgets we have so far, such as you can read the cacti logs or server configurations, and even access the user upload files on Redmine. Here we demonstrate a Redmine RCE through double jumps. Under the Redmine installation folder, there is an instance directory that can jump to /var/lib. And within the folder, the config directory can also jump to the /etc/redmine, which contains Redmine's database configurations and secret key. So by using an unsafe rewrite rule, we can access the secret key by two symbolic links. And since Redmine is a Ruby on Rails application, the content of the secret key file is actually the key used for signing and encrypting. So the next step should be easy. Generate a malicious object, sign and encrypt with the known key, and put all of them to the cookie. And you can get code execution through server-side deserialization. Okay, the last attack I'm going to introduce is the confusion based on the handler. So back to our first question. Why can both directives, one for adding a handler, one for adding a content type, can get the PHP running properly? This is actually due to a legacy conversion in Apache, or you can say it's part of its technical debt. Before Apache enter the main handler, if the handler field is empty, the Apache will take the value from the content type field as its handler. So our third attack is all around this behavior. Sometimes the content type can be converted into the handler. Sometimes the content type can be converted into the handler in the Apache HTTP server. So how it could be wrong? Let's give you something fun first. Imagine that your server is running PHP using add type. And now you are accessing the file config.php. And normally, since the file extension is .php, so the Apache will assign the corresponding value to the content type field based on your configuration. And the later PHP will note, oh, it's his responsibility to handle this request. The normal process is good. Before entering the main handler, because the handler field is empty, So the legacy conversion we mentioned earlier will convert the content type field into the handler. And so that explains why both add type and add handler are the same. However, what if there is any other module overrides the content type field before the legacy conversion? For example, by triggering a filter error in the mode security module. So when there's an error, the mode security will think, oh, I made some mistakes, so I want to send out some error message. Since the error message is in HTML format, the mode security module also sets the content type to HTML. And the configuration file, which is supposed to be executed as PHP, is treated as a plain HTML now. So it is exposing all the sensitive information outside. So this is our first primitive of the handler confusion, to disclose any PHP source code by overriding the content type. However, if we think this deeper, the nature of this vulnerability is actually caused by there are no clear guidelines for the use of the content type field. It can be set by configuration during the request or used by the content type header in the server response. While using this field, the Apache cannot distinguish which one it is. So following this idea, if we can control the content type field, we can invoke arbitrary handler. So is that right? It's very promising. However, the situation is not as simple as it seems. In practice, all the code paths that can modify the content type are all after the legacy conversion. So even if we can modify the content type through the server response, it's useless because it's too late. So what can I do? We call the IFC to servers. IFC 3875 is the specification for the CGI. And the section 6.2.2 introduced the local redirect response. The mechanism works like this. If the CGI returns the status of 200 and include a location header, the Apache will treat this location as a local redirect response. The redirection should be done in the server side. The server-side redirection will first open a new HTTP lifecycle and copy the original content type to this new request, and then process the request as the normal request. For example, if you control the response headers of the CGI, that means you can control the whole content type field and the status code. So when Apache sees the status is 200, it performs the server-side redirection to start a new HTTP lifecycle. And before entering the main handler of this new HTTP lifecycle, the legacy conversion we mentioned earlier will copy the content type you controlled into the handler, that giving us the ability to code arbitrary handler. So this is our second primitive, to invoke arbitrary handler. Basically, the entire CGI family follows this feature, including but not limited to the WSGI, fast CGI, and the UWSGI. As for how to trigger the server-side redirection, here we provide two scenarios. One is CRLF injection, and the other is SSRF. And here we will use the CRLF injection as the example. In the normal cases, a CRLF injection in the HTTP header will be treated as a XSS because there is no other server-side processing. However, today, you can override the content type to a handler called the server status. And then you can leak sensitive information that should be only accessible from the local. You can also easily transform the arbitrary files into your PHP backdoor by overriding the handler to the PHP module. You can even achieve SSRF through the proxy module. And this SSRF allows you to control the request headers and read all response. And it's awesome that this SSRF can also access the local Unix domain socket, all thanks to the convenience feature brought by the proxy module. And lastly, let's demonstrate how to turn this SSRF into RCE. Here we used a common trick in CTF. The official PHP Docker image by default comes with the peer, a PHP extension manager. And the peer CMD is the entry point for the package manager. We can leverage the SSRF to access the peer to do further exploitation. For example, we exploit a command injection in the run test command. And we can get a reverse shell easily. So today, you learned a new way to exploit the CRLF injection. So please do not report the header-based CRLF injection as the XSS again. It's really a waste. This type of vulnerability has the potential to become a RCE. Okay, here my presentation is nearly coming to the end. But before closing that, I would like to say, maintaining open source is really challenging, especially keeping a project for 30 years. You have to make it convenient for end users and compatible with all versions. The entire development process is built upon a pile of legacy code and technical debt. So if there are any Apache developers in the audience today, I want to say thank you. Okay, let's have some short takeaways. Today, we have discussed the question mark is a powerful tool that can truncate arbitrary paths or bypass the authentication. And the rewrite rule contains a trap to allow the attacker to access the system root. And lastly, by controlling the response header, you have the ability to invoke arbitrary handler through the legacy conversion. There are also some future works. For example, different installations have different configurations, such as the Apache on the FreeBSD or even on previous applications. They could have the more allowed by default access control or more local gadgets. Also, you can imagine that in the real world, there must be numerous rewrite rules to be figured out, access control to be bypassed, or hidden CGIs out there. So applying all the technicals we discussed today is now your mission. So this is the end of my presentation. If you have any questions, here's my contact information. And thank you for being here today. Thanks.